Alright, so for this problem, we have a circuit like this, and we have the resistance and the reactance of this inductor and the total current for the circuit. And these two components, they are connected in parallel. And so what we want to find, first we want to find out YT, and then we want to find E, I, R, and IL. And then we want to find out the average power. And finally, we want to find out the power factor. Okay, so let's see. A wants to find out the admittance, the total admittance YT, and because this is a parallel circuit, so that means we just add the individual admittance for the components together. So we will have YR plus YL. Okay, and YR we know is 1 over resistance, and YL is 1 over J. The actually is 1 over ZL. Okay. ZL. And ZL we know for ZL. Let's just do one more. 1 over R plus 1 over ZL is equal to J XL. Okay. So 1 over R. R is 10 ohms plus 1 over J 20 ohms. 20 ohms is the XL. Okay. So it's equal to 1 over J becomes negative J. So this is 0.1 S minus J 0.05 S, because 1 over 10 is 0.1 and 1 over 20 is 0.05 and 1 over J is negative J. Okay? So that would be the rectangular form for this total admittance. Okay. If we want to convert this into polar form, then we will have 0.1 square plus 0.05 square with an angle negative 0.05 over 0.1. Okay. So if you do the calculation, it will be equal to 0.112 S with an angle negative 26.6 degrees. Okay. So this will be the total admittance of this circuit. Alright, so then B, we want to find out E. What is E? E, remember, E is the voltage for the total, for the whole circuit. So we have the current, we have the total admittance. So then we can get the E. Okay. So because E is equal to I times ZT, right? I is current, IS times ZT, and ZT is equal to 1 over YT. Okay. So it becomes IS over YT, because ZT is equal to 1 over YT. Alright, so IS here is 2 amps with 0 angle, and YT is here, 0.112 S with angle of negative 26.6 degrees. So you just use 2 over 0.112, and for the angle is 0 minus negative 26.6. Okay, 0 minus negative becomes 0 plus positive. So it's 2 over 0.112 becomes 17.86 volts with an angle 26.6 degrees. Okay, so that will be the voltage for E. All right, so for IR, remember we can use current divider rule. For current divider rule, actually we will have E, current divider. Or I mean, because we have the total voltage over this circuit, and these two, they are connected in parallel. So the voltage E will be on R. So for IR, it will be equal to the voltage over the resistance. So it will be E over R. Okay. So it's E is here, 17.86 volts, 26.6 degrees over R. R is 10 ohms. Okay. So it's equal to 1.786 amps with 26.6 degrees. Okay. So that will be R. And IL will be equal to E over ZL. Okay. So because IL based on Ohm's law, current will be equal to voltage over the impedance. Okay. So it's equal to E is what? E is here. It's 17.86 volts with 26.6 degrees. And ZL we already know that it's equal to JXL. Actually, it's XL with 90 degrees. Okay, and XL is here, 20 ohms. So it's 20 ohms. So if you do the calculation, it's 0.893 amps with 26.6 minus 90 degrees. Okay, so it will be equal to negative 63.4 degrees. So you can see we find the total admittance and the voltage and current IR, current IL. So let's find out C and D. Okay. So we have to erase this. Alright, so C, we want to find out the average power. So for average power, we can do like E, I, and cosine theta t. Okay? Alright, so E, we already calculated. E is, let me put E here. E is equal to, we got this from B. Okay? So E is equal to 17.86 with 26.6 degrees. Okay. This E is the amplitude. Okay. So it's 17.86 volts times I is here. The IS actually. Okay. Is 2 amps. The RMS value for I is 2 amps, okay? And times cosine, and this is the, theta t actually is the theta for the is the angle for the ZT is the angle for ZT. Okay, so angle for ZT, YT. Let me put YT here. YT is equal to it's from the first step. So YT is equal to 0.112 S with negative 26.6 degrees. Okay. So theta t is the angle for ZT, and ZT is equal to 1 over YT. So 1 over YT, the angle for ZT is equal to a positive 26.6 degrees. Okay, so this will be the expression that we can use to calculate for the average power. And if you multiply all these values together, it's 31.94 watts. Okay. All right. So finally, we want to find out the power factor FP, and we know FP is cosine theta t. Okay. So we have that is cosine 26.6 degrees, and if you do the calculation, it's 0.894. And look at the voltage and the current. So you can see current has a 0 degree angle, and the voltage has a 26.6 angle. Apparently, the current lags the voltage. Okay, so that means the power factor is a lagging factor. Because the current lags the voltage.